I'm sorry for the miswriting. The good writing is there.
Merci, Gilles. I'd like to begin by thanking Javier Paso and the entire Caipan team for organizing this important workshop and inviting me to participate along with so many others of you who are very gifted and knowledgeable investigators. And I think it's important that the emphasis on methodology is essential, and we should have been doing this 20 years ago. This morning, I'm going to build my presentation around photographs primarily because they can more quickly present concepts in less words. And so my words will remain unspoken in some cases, but I begin, if this system will work. Here's the subjects I'm going to try to cover today in the short period of time I have. After a few introductory remarks, I'm going to review challenges that we face in investigating pilot and air traffic controller sightings and reports. Then some words about cockpit documentation, which is very important, reconstructing the aerial encounter, and then a few words about data integration and analysis, and then some conclusions. But I will say that I've prepared a more complete paper that I hope is available eventually, which will fill in some of the gaps here this morning. Unidentified aerial phenomena continue to be reported by pilots and air traffic controllers around the world. They are good witnesses. I'm convinced of that after interviewing so many of them. And this slide gives you some of the reasons why they are good witnesses. I'm not saying they're perfect. They're human. They're subject to illusions and dynamic motion effects and so forth. But nonetheless, they generally have their reputations and career to be concerned about, so that when they do come forward with a report, I take their word that it's they're sacrificing something to make this report. And despite many decades of private and government-supported research, we're still not very much farther ahead, very frankly. I'd like to use for just a moment a metaphor that has been called the black swan metaphor. The features of a black swan event. It's a rare event that lies outside our normal range of experience, which most UAP encounters do, produces an extreme impact. Usually it changes the life in the belief system of many of these pilots, most of the pilots actually. And these events often lead to a later explanation or an attempt to explain the phenomenon in a more understandable or predictable manner. And we find this happening a lot with pilots. They're trying to explain what happened and having difficulty doing it. I suggest that our future methods to study UAP should begin to focus more on invisible and unexpected black swan kinds of events, low probability, nonlinear, events that may not fall into a Gaussian distribution statistically. They're so infrequent. How are pilot sightings different from ground sightings? This perhaps is just obvious, but I will just briefly review them. The pilot is enclosed in a cockpit of an airplane. Many people are not. Perhaps a policeman in a car would be. But a policeman in a car is in a two-dimensional world. A pilot is in a three-dimensional world, right? Constantly moving. Very few stable visual references, and thus motion illusions that can occur. He has a great competition for attention. He may be trying to fly the airplane, but something's happening outside the airplane that's so compelling that his attention is shifted over outside the airplane. the personal threat level can be much higher because of the possibility of an accident, a collision, if you will. And we've studied a number of these kind of cases. And his professional reputation may be well influenced if he does come forward with an official report. And generally, I think it's fair to say that his education level and experience level and even intellect generally are higher than the man on the street. Now, I'm sure you can debate that, but it's a controversial statement. So, interview challenges. I maintain that we ask the fundamental journalistic questions: who, what, when, why, and where, of course, but allow the witness a full opportunity to say everything he has to say without you saying anything. You don't bias him. Let him tell his story as best he can without jumping in with questions, for instance. By doing so, you often introduce your own personal biases and assumptions, even leading questions you're not even aware of. I suggest that you and I order the questions in a logical, consistent fashion that's been pre-planned. I think that's another important thing to do. Well, I have to move on in the interest of time. Let me comment briefly about documenting the cockpit in which this event takes place, for aircraft pilot sightings at least. When we do research with NARCAP, we document with stills and video all aspects of the cockpit of the airplane whenever possible. And since 9/11 in America, this has been increasingly difficult to do. Access to cockpits is becoming very, very difficult. I hope you can read some of the details here. Number two, it is possible to obtain manufacturer specifications for virtually any airplane now that isn't classified, at least, military classified. And those documents can give you very valuable dimensional information, extremely important, angular information and so forth. And then, if possible, measure the optical transmission characteristics of the window, the windshield, if you will, that surround the cockpit. Here we have Captain Schultz in an L-1011 soon after his experience in 1981. And we're sitting at the airport, San Francisco Airport. I don't have time to give you the background on this very important case, but here I photographed him on the left as he was sitting before the object appeared. He was on autopilot control, just relaxing back, his head was against the rest, and having a nice flight like a passenger. The instant the object came into view, he lurched forward, put his hands on the instrument panel because he thought there would be an impact, a collision. And you see him here on the right at that point. Here are two more views from a different point of view, different dimension. Look at the window outline, the frames, which are very important to document. Here's a case from Mexico, 1975. A photograph upper left from directly behind the pilot. It's a Cessna, a Piper, light aircraft, single engine. And then upper right, I have a laser here, don't I? Yes. This picture here shows him sitting where he did at the time when this event occurred, but turning his head 90 degrees left, looking out as wing, which you'll see in a moment, at the object that was hovering above his wing. Here, he's another 90-degree photograph, but he's looking forward. And then I sat where he sat with the camera at the reference eye position, where the cockpit is designed for each pilot, basically, optically, and took a picture of the forward window here. Well, this is what the Piper wing looks like, looking out that left-hand window, if you will. Another thing we do is ask all our pilots to sketch, make a rough sketch. They're not artists, but still they do a pretty good job. This is his drawing of what he said he saw that day. This is one of 3 objects, identical objects. You're probably familiar with this case. I don't know. Well, here's another case on the left from northern Germany, 1976. Single-engine propeller plane. And this is the pilot witness's sketch he made for me, showing basically the shape and angular size, if you will, as it was approaching the airplane, and then settling up and following him for, I think, 10 minutes off his left wing. These sketches are not meant to be particularly accurate, but they can prompt new questions, which I think is really very important to do. This case over here is the Lake Michigan case that I mentioned. You saw him sitting relaxed in that L-1011. Here's his sketch that he made. This is the forward window. Here's his left side window, and then the far left window is back here. Here's the horizon. And I asked him to sketch in on a piece of plastic that I had pasted up on the window with a grease pencil the size and apparent position and location of the UAP at different times, approximately 3 seconds apart, 2 seconds apart. So you have number 1 when it was first seen, 2, 3, and so forth as it comes down near him. Here's a sketch again you saw from the Mexican pilot, but here's an example of him actually drawing on these plastic sheets in this Piper aircraft. And you see this reconstruction right here is relative to his own eye. He's in the cockpit, surrounded by that environment. Here's his drawing of the object when it was first seen. Approximately the third object that came. There were 3 identical objects that surrounded the airplane. Here's where it was from his forward window, right there. And here's the German case showing the airplane passing this way. It's a plan view, flying to the south in this direction. Here's this UAP off his left wing at some unknown distance. And these are 2 American F-4 Phantom jets that came up to investigate and chased the object off, by the way. This is his sketch. And then here's his drawing of the cockpit from kind of an eye-point view, showing the object as it passed in front of him and rose out of sight. Well, here's another case, a fairly recent case from Los Angeles, a DC-10 cargo flight after about 2 a.m. in the morning. This is the pilot's description or sketch here on our pilot reporting form. But because they're not artists, we don't expect them to be artists. So I arranged for a professional artist to meet with him and to reconstruct this drawing here, which was almost photographic quality. Okay? I keep pushing the wrong button. And here's that same artist's view of the nighttime cockpit that was in. Here, the witness is over here on this side, sitting here. And this was the relative position of that object. He thought he was going to have a mid-air collision. It was that close. And after 5 so seconds, it was traveling in the same direction and speed as he was, and he was amazed. He could not believe his eyes. He thought it was oncoming landing lights of another jet plane, and he had about 3 seconds to live. That's how frightening it was. The object, I don't want to get into details because today is not about phenomena so much as measuring them and recording them. But the phenomenon, if I can get back, did this. It accelerated horizontally to about here, and then it rose up into the nighttime sky. In about 5 seconds it was gone. Nothing on radar. There was no radar confirmation of that. Now, when we do this reconstruction here, now this is from memory, on this plastic sheet that is on the windows, what it allows me to do is to do measurements then of triangulation. Here's the flight path of that L-1011 traveling from bottom to top. The autopilot was on at all times, and so the pitch and roll and heading and everything didn't change. That's a stable viewing platform, so that we can now plot the apparent flight path coming in, doing a very high-speed turn about here, and going away. We calculated about a 20 G turn right in here, and then about 1,000 miles an hour going away. We can also calculate the angular size of the object, which you see here. This is visual angle in degrees on this axis. This is time in seconds. The total, most of the event happened within 5 seconds time. And that one period of that 5-second time in this man's life changed his life. He'll never be the same. He's a combat pilot in Korea, Navy pilot. Didn't believe in them before. Now he's a full-time believer. That's a whole nother subject I can't get into, basically. All right, reconstructing the event. We recommend replaying the event in this order, starting here, with one witness in the simulator cockpit or the airplane cockpit, and having him go through in real time what he experienced from memory. Then we bring in, he goes away and has a cup of coffee, and the co-pilot comes in. That's him, witness number 2. And he does the same thing in the same cockpit, right? Then if there's air traffic control somehow involved in this event, he would be brought into this reconstruction, and everything's being recorded, of course, in real time. And then we replay here with both witnesses in the cockpit side by side. So first of all, there's no contamination from one witness to the other, which is important. But then we get the interactions of the 2 witnesses here. And then we have the phase, which we call the validation phase, looking for difficulties, conflicts, changes in the story, if you will. Do the 2 men agree in the details, or do they not disagree, or do they disagree, and so forth? Reconstructing the event in a simulator rather than the airplane. As you all know, we have a great variety of simulators these days. Gee whiz. Ranging from very expensive flight training airline simulators with motion base and sound and extremely realistic outside vision. Here's an example of one of the virtual in-flight scenes here on the right. That's a computer-generated virtual image. To small cockpits, general aviation, Pipers, Cessnas, and so forth, that have also, many of them have high-resolution outside scenes. Why do we do this? So that we can surround the witness in the context it happens, and it causes the memory to unlock, if you will. I'm running out of time, I think. How many, 5 minutes? Oh, great. Okay. Super. The internet today has changed a great deal of how we integrate information, not only collect it, but can integrate it in almost real time. And so in the case of navigation, in this case, flight-related information, we have weather stations, in this case, England. You can click on a button and know instantly what the weather is there at that time. You can go back into historical records and reconstruct it if the case is older. I mean, you all know this probably as well as I do, that Google Earth gives us a whole new perspective on where we are on this planet and what's around us. And Flight Track gives us the opportunity to know where any commercial scheduled airplane is at any time, altitude, airspeed, direction, heading, so forth and so on, except the Malaysia Air that disappeared. We don't know about that. This is an animated side. I don't think we have time to see it, but I'm zooming down to Charles de Gaulle Airport down here in Paris to show the level of resolution. Some of you may not have seen this kind of a presentation before. That's extremely valuable in reconstructing the aerial navigation details that we must understand. Where are the radio fixes? Where's the potential for electromagnetic interference? Because these airplanes can often detect some aspects of that EM spectrum. We have weather data, in this case lightning detection. So if some of you are concerned about the interactions between electrostatic effects and UAP and electrostatic dimension or characteristics, you have real-time data here that might relate it. You have magnetic field distributions, topography, if you will. This happens to be Europe, but it's worldwide. We have the ultraviolet index if you're concerned about atmospheric transmission and wavelength intensities, in this case over America. And this was for June 20th. I just took this off before coming here recently, and it's changing moment by moment practically. So for those of you who are concerned about the Earth environment near atmosphere of characteristics, this level of information is unprecedented. We've never had this before, still fairly recently. And it's extremely valuable in reconstructing, accurate reconstructing sighting events made by pilots and air traffic controllers. Let me conclude then by saying that these reports that we're getting in NARCAP from pilots in America and our colleagues in 14 other countries now that are establishing other NARCAP groups, if you will, we're integrating this near real-time data with, from the internet primarily, that we think will give us new insights as far as what the phenomenon is constituting. I'm suggesting here today that the methodology from a conceptual point of view should really be like a fisherman's net, and that net should have be a very large net to catch lots of fish, if you will, but the weave of the net should be very small. And I know some of you here today are doing research along that line for ground sensing stations. Dr. Chernus is developed and working with a team with 41 almost simultaneous wavelength monitoring capability. That's what we're going to need. Now that's from the ground looking up. In aviation, we have satellite technology looking down, we have airborne radar at altitude, and we have ground radar looking up. But I'm not convinced radar is going to solve our problem because of stealth and other concerns. So the net, I think, has to be very creatively planned. It must include both psychological and physiological and sociological data, as well as physical hard science data. Don't leave that out. It's extremely important. And finally, government aviation officials should be encouraged to collaborate with us all in a more open way. They have not been very open so far. Now, fortunately in France, you have a much more open posture on that we have in the West, in America. And we're still fighting that uphill battle. But nonetheless, we must have the cooperation of aviation officials so they will encourage pilots to make reports and air traffic controllers. They're not doing that now, where I come from. They're beginning to do that in South America, fortunately, but we're behind, I'm sorry to have to say. And I'm suggesting that we need an international data clearinghouse where we can truly share data across cultural bounds, across national boundaries, and of course military classification issues become a problem there. We understand that. But there's a great deal of open data, open, free scientific data that we can have access to. So that's fundamentally my presentation, and thank you very much for your attention.